Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we've had a problem. Today we want to talk about chemical equilibrium. Now you've probably heard about equilibrium before. It's when things are balanced, right? Right. But when we talk about chemical equilibrium, there's a very specific definition. You know what it is? It's when the rate of the forward reaction equals the rate of the reverse reaction. Imagine an island connected by a bridge to the mainland. Maybe Galveston, Texas would be an example. And there's Houston and there's Galveston. And let's pretend, for the sake of argument, that there's one bridge between these two locations. And what happens in the morning? Lots and lots of cars travel across the bridge to the large mainland of Houston. And that's in the morning, right? What happens in the afternoon? Well, they drive home. So equilibrium is established over the course of a day because the number of cars that go to Houston in the morning is equal to the number of cars that go to Galveston in the afternoon. The rate of the forward reaction is equal to the rate of the reverse reaction. But wait, is there another metaphor that might make more sense to a bunch of teenagers? Yes, there is. Let's say that we have a type of a reaction that happens at a typical high school. Let's say you have this reaction. A boy plus a girl makes a couple. Is that a reversible reaction? Doesn't every day a student walks into the school, possibly, and they decide to become a couple? Of course. But what also happens? You know this is true. Oh! Couples break up. And if you're on a given day at school, I'm going to make an argument that probably this forward reaction is equal to this reverse reaction. The rate of the forward reaction is equal to the rate of the reverse reaction. Guess what? In chemistry land, it still applies. There are certain reactions that are reversible. They can go back and they can go forward. Now you may have seen this chemical before. Acetic acid, HC2H3O2. That's vinegar. Like vinegar you put on your chips, right? Vinegar, salt, right? Vinegar chips. And it has a reaction. By the way, I shorten it. I don't put the arrow. I just kind of have one end of my arrow. We chemists do this. What happens when vinegar is in water is it partially dissociates into hydrogens and acetates. But if you were to dive deep into the bucket of vinegar, what you'd find is that some hydrogens and acetates are getting together to make acetic acid. And some acetic acids are breaking apart into hydrogens and acetate. It's kind of like this reaction up here, I guess flipped. Same idea is that they're going back and forth and back and forth. So many reactions are reversible. Now, this is a weak acid reversible reaction, but there are many other types of reversible reactions. One you may not realize, this is a weird one. You might have learned that there are certain things that are insoluble. For example, silver chloride is an insoluble salt. It's a solid, right? Well, we've been lying to you. Do you realize that some of it breaks apart into silvers and chloride? So if I have a beaker full of silver chloride, the vast majority of it is the silver chloride. But some of it is breaking apart into silvers and chlorides. And some silvers and chlorides are forming silver chloride. There's this equilibrium. The rate of the forward reaction is equal to the rate of the reverse reaction. And that, my friends, is what chemical equilibrium is. Houston, We just had a problem, but now we got it. Forward, reverse. See you in class.